Hello everyone, my name's Annette Davison. Today I'll be talking about engineered nanomaterials in water, should we be concerned. I'm presenting this work on behalf of myself and my colleague Ian Law. Ian is the principal of IBL Solutions. I'm the director and shareholder of the risk management company RiskEdge and also the startup water quality information business, D2K Information. My background is in microbiology, environmental law, risk assessment, and water management system auditing. So just to do a little bit of historical background, as you can see from this slide, we have already published in this area, and I would like to acknowledge that this presentation leans heavily on our previous work. Ian likes the engineering side of things, and my point of interest is how ENMs, or engineered nanomaterials, fit within a governance framework for utilities. And by this I mean, at what point should utilities be aware of emerging hazards and do something about them? So when has a hazard actually emerged? I should also point out before I upset some people that I do also like the science side of things. So just a little bit about the background then for ENMs. There's a global nanotechnology industry which is predicted to reach 70 billion US by next year. ENMs have many uses, including in what you might think are obvious industries, such as the electronic and medical industries, but they're also found in a diversity of industries, including the food, cosmetic, and agriculture industries. Size varies from 1 nanometer to 100 nanometers, and the most studied types are silver particles, followed by zinc oxide, titanium oxide, cerium oxide, silicon dioxide, and carbon nanotubes. So our key questions then from an industry perspective are, how efficiently are ENMs removed by wastewater treatment plants? How efficiently are ENMs removed in drinking water and potable reuse applications? And what actually is their human health risk? So while I used to be a frontline researcher a long time ago in a galaxy far, far away, Ian and I are now what we call information synthesizers. However, what we are is experienced water industry professionals who are concerned about the rise and potential risk of ENMs to our industry and also to the public and environmental health in general. So in the documents shown here, ENMs have been mentioned, but there is much research to be done, including in Australia. Our question is, should the water industry really be worried about ENMs? So this is quite a wordy quote, as is the way of quotes, but the key points are that ENMs are an emerging contaminant group of concern and that we are going to have problems in evaluating their toxicological and ecotoxicological endpoints. So this is from the work undertaken by Stuart Kahn. So research on ENMs is ramping up in Europe, the US, Singapore, China, and Australia. This slide is really a mishmash because that's how the situation seems to be. No central point for information synthesis and direction. So back in 2010, even the CSIRO had a look at ENMs in relation to their fate in sewage treatment plants, as you can see here, fate of manufactured nanomaterials in the Australian environment. And some other contributors to this work, as you can see, there are actually many. So we've got evaluating nanoparticle breakthrough during drinking water treatment, removal of silver nanoparticles in simulated wastewater treatment processes, transformation of PVP, coated silver nanoparticles in a simulated wastewater treatment process, and one for me there, the effect on microbial communities, survey of food-grade silica dioxide, engineered nanomaterials as emerging contaminants in water, and Paul Westerhoff, who you can see is one of the primary researchers in this area. But out of this, there's a range of conflicting findings, as you can see. Yes, ENMs are removed during water treatment plants, sort of. ENMs are removed during some stages of water treatment. No, ENMs are not removed during wastewater treatment. Yes, ENMs are removed during some stages of wastewater treatment. So you can see that it's a fairly conflicted sort of picture. And then as of August 2018, another review was published by Westerhoff et al. So that was Paul Westerhoff, who I mentioned before. They note that engineered nanoparticles are currently orders of magnitude less common than natural nanoparticles in waters that flow into drinking water treatment plants, and that we should be more concerned over the corrosion byproducts released from distribution pipes or in-home premise plumbing, which can release incidental nanoparticles into tap water. The occurrence and toxicity of incidental nanoparticles rather than engineered nanoparticles should therefore be the focus of future research. However, given the size of the industry, I don't think we can just let our focus on environmental sources of ENMs slip. This source should still be on our radar. So just to conclude for this part, what we know for sure is there are gaps in our knowledge. So there's a bunch of unknowns based on our current knowledge. Like, we really know some stuff, but we don't have the whole picture. So we don't know what is a human ENM exposure through things like treated wastewater, biosolids, recycled water and drinking water. Can all ENMs be analysed with current methodologies? Are release rates of ENMs from commercial products understood? What compounds affect ENM removal? We know that some things can adhere to other things, so how does this actually affect their removal? Is a transformation in the environment? And what treatment barrier is effective for which ENM? These are all the unknowns that still really remain to be answered. So at this part of the presentation, I'd like to come back to the Australian Drinking Water Guidelines and bring your attention back to the 6 guiding principles. So you can see, all of you, I'm sure, will be familiar with these guiding principles that are in the Australian Drinking Water Guidelines. So I'd like to bring your attention to particularly Principle 2 and Principle 6. So perhaps ENMs at this stage at least may not be so much of an issue for drinking water, but we certainly cannot discount the risk for potable reuse as well as their ecological impacts as well. So if we look at Principle 2, the drinking water system must have and continuously maintain a robust multiple barriers appropriate to the level of potential contamination facing the raw water supply. And so if the level of potential contamination is going up because of things like trade waste issues and not adequately controlling ENMs in trade waste, Principle 2 applies. And then with Principle 6, ensuring drinking water safety and quality requires the application of a considered risk management approach. And the key word there is considered. So we really need to understand what's going on in our catchment to understand the risk and understand what barriers need to be in place. And so, as you saw from the previous slides, because of the gaps in our knowledge, we really need to be paying attention to Principle 2 and Principle 6. As I mentioned before, size does matter. And here we've got a slide showing particle size and removal potentials. So we've included this size as it provides a helpful visual on the range in which ENMs sit from a size perspective. You can see that they are way smaller than bacteria, protozoa and microplastics, and more in line with the size of viruses. So their full removal, we are really looking at advanced treatment. So given this background, are ENMs on the radars of water utilities? So we've seen at least a couple of examples where utilities have picked up on ENMs. Water Corporation in WA has ENMs on its risk register and also in a 2016 fact sheet. The Public Utilities Board in Singapore has been investigating ENMs since 2012. So some utilities are aware of the potential risk, and I've seen, as well as the information that's on this slide, I've also recently seen other information for other utilities as well, where ENMs are now starting to get on their radar. But what about analysis? So in November 2016, we had a workshop that Ian convened, at which I was in attendance, as well as representatives from industry and academia. As you can see, and as noted by Stuart Kahn in an earlier slide that I presented, one of our findings was that the analytical capability for ENMs is currently limited, which really does hamper our ability to further understand and manage this group of hazards. So, as you can see here, we've got no easy, quick, low-cost method currently available. And we've got single particle ICP-MS favoured, but it's largely limited to particles greater than 20 nanometers and is best suited to silver nanomaterials. An acceptable method to cover the 1 to 100 nanometer size range is something that we need. The impact of water matrices is not fully understood. Now that's important because we're looking at different types of water products, not just drinking water, so we might have different qualities of recycled water. We might be looking at sewage sludge for biosolids. So it's important that we understand the different types of water matrices that we have to deal with, especially if a log reduction value approach is required for the treatment trains that we might have in place. Also, there's some talk about use of radioactive markers on ENM particles to enable measurement at low concentrations as well. So that's the background bit of ENMs done. I'd now like to talk more about governance and how emerging hazards such as ENMs need to be captured. So how do we actually understand the context? So I'm sure all of you will be familiar with this diagram. It's the framework for management of drinking water quality from the Australian Drinking Water Guidelines. So the framework for management of drinking water quality shows that we have to understand context by knowing our stakeholders and operating context, as well as understanding the system from which we derive our source water and produce our finished product. So you can see there, element 2, it requires us to have a drinking water quality in place, look at our regulatory and formal requirements, and also at engaging stakeholders as well. But as it shows in element 2, how can we even assess water quality data if we can't measure the hazard in the first place? So element 2 is all about water supply system analysis, assessment of water quality data, and hazard identification and risk assessment. So put simply, governance can be summed up in 3 words: authority, responsibility, and accountability. If we don't yet have enough information to understand something, there is a responsibility to work out what needs to be done to better understand and manage that something. If not, you will be held accountable as a utility. So what does corporate governance look like for product quality? So first of all, we need to understand and manage risks from catchment to consumer, make sure water is fit for purpose, look at what unsafe actually means, and in some cases unsafe could mean likely to be a risk or even suspected to be a public health risk. Now that's important, so if you suspect something might be a public health risk, you really should be doing something about it. And we would say that ENMs actually fall into that category. So if we don't understand what the risk is and how to manage the risk, then we really don't understand the governance around product quality. So this information applies to product quality, and similar provisions also apply to work health and safety. So the Work Health and Safety Act generally impose, or any acts generally impose a duty on a person conducting a business or undertaking to understand and manage risks. So product quality is about the consumption side of things for as far as drinking water is concerned, but it also may be for workers whether their worker health is going to be affected by ENMs. So that might be through aerosols or handling residuals or anything that might impact on them where there might be an exposure route for ENMs. So some key questions then. Some of you will be aware of the Walkerton incident, which happened in Ontario, Canada in 2000. So several people died from drinking contaminated water, and I've included this quote here. So the offenders are being sentenced for their failure to discharge their public duty and thereby endangering the lives, safety or health of the public. And this was from Justice O'Connor's inquiry. So I've included this quote because while the hazards in the Walkerton incident were bacterial, the quote could equally well apply to any hazard. So if utilities do not understand emerging hazards such as ENMs, they could be failing to discharge their public duty and thereby endangering the lives, safety or health of their end users. So as you can see on this slide, there are some key questions. So what should you have known and when? So has the hazard emerged? Is it on your risk radar? And what should you have done and when? So current, understand if the hazard creates risk for your water product, identify whether risk is tolerable, and identify if controls are required. And then future, program required controls, monitor controls for effectiveness, and keep watch. So there are some difficulties for utility E&M governance. So ENMs in the environment are likely to increase, as I showed you right at the beginning. There's much research being done, but is there a water industry focus? That's the question. Health risks are not well known, but we know there are some. And due diligence means actively understanding the issue, not putting it to one side and not putting your head in the sand. So in summary, the E&M industry is growing rapidly, and there's going to be a likely increasing presence of ENMs in our wastewaters and our catchments in general. Research is being carried out into ENMs in many countries of the world, including here in Australia, but it really does lack coordination and utility input as far as we can see. We need to have a clear understanding of the health risks and the exposure pathways. So at this point in time, we think that the jury is not only out, but it still does not have enough firm evidence on which to deliberate. But we think there is a way forward. We think there are a couple of phases to this. So the way forward, phase one. Firstly, understand the E&M risk and the source. So that could be understanding your trade waste, making sure you've got ENMs in your trade waste policy, on your risk register, that type of thing. Understand your operating context for ENM. So that's what are your statutes and regulations that you have in place? What might compel you to understand this? Determine the public health impact. Establish reported ENM removal efficiencies. And where possible, make recommendations on public health risk status of key ENMs. Now, just going back to that operating context one and determine the public health impact. I've seen quite a few cases now where people have got ENMs on their risk register and they're there, and that's a good thing. And what they've said is that we're really uncertain about this risk at the moment. So that's a really duly diligent response. So if you can show that you have identified these things, they are on your radar and you're keeping an eye on them, that's a good start from a due diligence perspective. And then what we can do is fall to an industry-wide perspective in terms of looking at these things and how we can tease out the risks to us as an industry. And so lastly then is phase two. So phase two is about establishing a better body of evidence, including improving methods for E&M analysis. We believe the goal of this research should be to establish catchment-specific rules depending on the endpoint for that source water into which the ENMs are being discharged. So that might be whether it's drinking water, for potable reuse, or other types of reuse or environmental water. So I'd like to finish by restating Australian Drinking Water Guidelines Principle 6. So ensuring drinking water safety and quality requires the application of a considered risk management approach, so a considered risk management approach. And that is what we're advocating for ENMs or for any emerging hazard for that matter. So understand and manage the risk appropriately. You really can't stick your head in the sand. Thank you very much for listening.